Welcome to the fourth installment of Grad 778, Elements of Research Computing. In this module, we're going to talk about documentation and reproducibility with R and LaTeX, or LaTeX as I like to call it. My name is Perry Williams. I'm an assistant professor in the Department of Natural Resources and Environmental Science, and my research focuses on statistical ecology, and that tends to focus on wildlife. So this week, we're going to have a series of short videos demonstrating how to do reproducible research, specifically in the environments of R and LaTeX, and using knitR to combine everything together. So most of the material used to develop these videos came from this book called Reproducible Research with R and RStudio, written by Christopher Gandrud. So if you're interested in some of these materials and want to learn more about it, this is a resource that's available online, I think for free, and you can check out more about it there. Okay, so a little background and motivation. So when we go to conferences or when we write papers, we are presenting the tail end or the summary of our research. So these are very abridged packages, and they include slideshows or PowerPoints or Beamer slides like I'm doing these modules in. Also posters at conferences. They include journal articles, books that summarize many journal articles, and then our research websites. And these are the project documentation that announce the findings of our project. But they are by no means the complete picture of the research that we've done. So sometimes these things are considered the advertising of all the research that we've combined to produce these documents. And this is especially true in computational and statistical sciences, when in the background, behind our findings, we have fairly complex or theoretically derived models that are supporting our inference that we're making. And it's becoming, as these models become more and more complex, it's more and more difficult for readers of our research to implement these types of models on our own. So the research also includes the full software environment that we've used to develop these models, the computer code that we've written to implement these models on a computer, and also the data we use to fit our models to our observations and to make inference from our findings. So when we separate our research from its advertisement, we make it difficult for others to reproduce our findings. And so this course is about making reproducibility of computational statistics or computational modeling easier using a few tools that are very nice for summarizing both our research and our advertisement. So in this workshop, we're going to introduce the tools to dynamically combine research with presentation of findings. We're going to do our statistical coding in the R statistical language for data analysis. We're going to use LaTeX markup language for documents, slideshows, articles, books, and web pages. LaTeX can also be used to make presentations. As I mentioned earlier, this presentation was made in LaTeX in an article type called Beamer. And then we're going to use this software, this R package, knitR or knitR, for R to summarize our R code into a document that LaTeX understands and then can prepare a nice aesthetically appealing document that combines both our code and our documentation. And to combine our knitR and LaTeX and our software, we're going to use the RStudio editing environment. So RStudio is a program that brings all of these tools together in one place. RStudio is what Kevin Shoemaker used in the second and third week of Grad 778 when he talked about an introduction and intermediate use of R. And R is really a nice single platform to do all of our coding, both LaTeX and R coding. And it allows us to bring in knitR to combine our LaTeX coding with our R coding. Okay, so let's talk about what this course is and what this course is not. The objective of this course is to introduce the tools to develop a workflow to maximize reproducibleness or reproducibility, to foster collaborations with other users of similar software, and to ultimately maximize our research impact by allowing others to have access to the models that we describe in our manuscripts and presentations so that they can incorporate those models and use those models for their own research. What we're going to do is provide basic templates that can be modified for your own research. So we're going to start from scratch with some R code, some LaTeX code, and a knitR document, and produce a very simple document that can be modified, and complexity can be added to meet the needs of your own research. What this course isn't is a single stop to become well-versed in R, RStudio, LaTeX, or knitR. So like a language, using these three environments is going to take repetition. And what we're doing here is starting with the basic building blocks that are provided. We are providing these documents so you can take them and customize them for your own research and build in the complexity that you're going to need. There are a lot of additional topics that can be followed up after this module, and they're all very closely related. And some of these topics, there are even modules within Grad 778. For example, this first one, version control with GitHub. Mitchell Gritz will be talking about using GitHub in a subsequent module in 778. There are other important topics, including how we gather data, how we can use R Markdown as an alternative to LaTeX. So R Markdown is a user-friendly version of LaTeX that lacks some of the functionality that LaTeX has, but it makes it easy to get started and to use, and they're very closely related. They have a lot of the same syntax. File management is another important tool that's closely related to reproducible research. Using projects, the projects feature in RStudio. And then using LaTeX to make presentations in Beamer like this presentation that I'm showing now. You can always recognize a presentation that's been made using the Beamer type in a LaTeX environment. And all of these additional topics are covered in this book that's freely available online called Reproducible Research with R and RStudio, the same book that I showed the title of on the second slide of this presentation. Okay, so let's talk about why we're using some of these softwares. Why we use R? Well, R is open source and free. There's a very active development community for using R. It really interfaces nicely with LaTeX and other markup languages, including R Markdown. And we can explicitly write down our analyses steps as source code so others can follow those steps, similar to reading the steps in a book. R is the dominant software used by statisticians. Another very popular software used is Python, and Python's more used in the data science field than the statistician field. And there's a module for, there are modules for Python as well within Grad 778. Okay, why knitR? So our statistical software came in after S statistical software. So S statistical software was a precursor to R, and there used to be a file management package called Sweave or SWeave that knitted LaTeX documents with S software. And when R became popular and widely used, the follow-up to that was knitR or knitR. So knitR is a literate programming, is a tool that will interface R code with LaTeX code. So you can write your code in R, and then you can use knitR within an R and W file to convert your R code to text code or tech code, and then you can compile all that documentation. So to get to these bullet points, literate programming is a crucial part of reproducible quantitative research. And what knitR does is highlights R code in presentation documents, making it easier for readers to follow, and you can highlight those R snippets within your code and copy and paste those into an R console and execute those commands. knitR also provides control over inclusion of graphics. So if you have your R documentation within your document and you want to have that R code produce a figure, you can modify and update that figure as you update your data and your commands in your R code to do it seamlessly with one click of the button. Whereas if you're using a separate software to create graphics, you're going to have to create your figures in that document, export the document somewhere else, import the document into, for example, a Word document, and then present that document and add your subscripts and everything to that. We can do this all within, we can do figures all within our same tech document when we use R, LaTeX, and knitR. Another nice thing about knitR is it allows us to cache our output from our R analysis. So if we have R functions that take a long time to calculate, we can run those once, cache the results, and if we don't change our code chunk, it's going to save that output for later use, and that when we recompile our document, it's going to not have to reanalyze that code chunk that we've cached. So some nice functionality available with knitR. And finally, why RStudio? There are a lot of text editing softwares. RStudio seems to be the dominant one used in statistics right now. RStudio is nice because it's a standalone editor for both text and markdown documents. It has many shortcuts, including automatically formatting our code to make it look nice and easier to read. It not only works well with LaTeX and R and knitR, but you can use other types of software too. Examples include C++, CSS, JavaScript, and a few other programming languages. RStudio has a very nice integration with version control, including Git, and it allows us to make everything more streamlined. When we use RStudio, there's simple compiling of both R and W and .tex files, text files. In other softwares like Emacs or VI, it's often a two-step process to first compile and then show our documentation. But with RStudio, it's one click of the button. And there's a less steep learning curve in RStudio than other text editors like Emacs or VI. All right, so the final slide in this first video here. What is reproducible research? Research results are replicable if there is sufficient information available for independent researchers to make the same findings using the same procedures. So that's our goal in developing this documentation that includes our statistical analysis and our code and integrates our data.